Nobody can prevent damages on their own. In every step of the design, installation, protection, and maintenance of underground utilities, there are people working diligently and innovatively to reduce damages. All these people need and deserve to have their stories told, which is what we do here at Planet Underground TV. Planet Underground TV is only made possible with the help of our sponsors. HBK Engineering and C-Scan. Hi, I'm Mike Perlak. In this episode, we're going to be looking at sewer, lateral, and sewer main inspections, as well as the locating of these lines in advance of underground utility construction projects. February the 1st, St. Paul, Minnesota. A plumber called to a home to unclog a sewer line struck a natural gas main, a plastic main. A main that had been installed in 1991, but installed through the sewer lateral of the home that exploded. What's interesting here is that the homeowner, a couple of days before, had tried to unclog the sewer herself using a 100-foot snake, but to no avail. So the plumber came out, and unbeknownst to him, the clog was caused by the gas main that had been inserted all those years before into the sewer lateral. The result of this explosion was that the Minnesota Office of Pipeline Safety mandated to its gas utilities that there would be inspections of sewer laterals for all future trenchless excavation installation jobs. The order also made mandatory the inspection of thousands of sewer laterals where gas lines had been installed in a trenchless manner in the years prior to the 2010 explosion.
It's very important for somebody to locate and televise the sanitary and storm lines just so you know where they are before you dig.
So one of the ways that we can confirm the crossbores as the camera's traveling up the lateral, sometimes it's clear as day that you've got a clay pipe, and then you look through the top of the pipe and there's utility sitting straight through there. But a lot of times you look around and you have a lot of trees, so if the utility has been broken through, a lot of times you'll have tree roots that are hiding that. So you may not see the utility right away. So what you may have to do is pothole down to confirm that's what it is. The last thing you want to do is tell the contractor that, hey, I didn't see any crossbores in here, this property is fine. And then have the risk of having a private sewer rodder come out and rod that line, and they couldn't see it because it was covered in roots. So we'll have to come up with plan B and hydro excavate down to get visual that way and verify that here's the utility, here's the sewer, and there's no conflict. We need 100% proof.
Not only just for excavating or digging, it's good to have a camera to see the integrity of the pipe. Older pipes like clay and stuff, they'll have water coming in, and next minute you might have a sinkhole. So a car drives through and you just got hollow out concrete and pothole. I mean, it would be very dangerous. What happens if you hit a water line and a sanitary line contaminate the water? I mean, who knows when it happened. It's just better off safe than sorry. Anything that can go wrong will go wrong, and just plan on it.
I'm a short timer in the industry. I'm at 4 years in the industry. And one of the things that still amaze me is from an engineering standpoint, before anything even happens, the investment or lack thereof in what utilities are there today. So I know when I need to put in another new utility, I know where to go the most efficient and safe way. And being able to do that research and investment up front, whether or not you want to call it subsurface utility engineering or not, and looking at those records and then interpreting and talking to those utilities.
The camera inspections that you see Pipe View America and Bloodhound performing are for the purposes of pre-construction. when they get their information to the excavator who's going to be putting in new gas pipe or new electric cable, these guys are going to start their digging. They're going to start their trenchless excavations. But sewer camera inspections can also be used in the design phase. We've asked Eric Bergstrom, Senior Vice President of HBK Engineering, to expand on the subsurface utility engineering process.
If we look at the subsurface utility engineering timeline as it relates to finding a utility in a given project, we have 4 different levels that could happen in time. These levels follow the American Society of Civil Engineers standards for the depiction of utilities in the subsurface environment. Level D is the most basic, and that is the utility atlas information that pertains to any given utility. So moving from level D, we move into level C, which combines survey of all the things we can see at the surface with that atlas information. That could include manhole covers, curbs, valves, trench lines, and anything that's visible to us, and bring those together to create the most accurate depiction of the utilities that we possibly can before we've done any physical manipulation of the ground or put anything in the pipes themselves.
So we're out here this morning locating sewer lines for the contractor, doing some work for the utility company. Basically, they're going to be putting some utilities underneath the street, and they need to know where the sewer lines are at. So we were out here yesterday cleaning the sewer mains, making sure everything was travelable for our tractors. We'll be traveling through the sewer mains, locating any sewer laterals that come into the main. From there, we will launch a secondary camera going up to the curb line to verify a depth and distance and location of the sewer line so that when the contractor comes out to do their work, they don't damage any private utility lines during their construction.
Not only, so you're paying us X amount of dollars to complete a job that we excel in doing. I mean, for one. And it's cheaper for us to spend a little extra time to locate the lines than if you hit a line in the street and had to dig up a whole street because you didn't want to spend the extra X amount of dollars for us to locate a line. It's a lot less cost effective if you just have us come out here and locate a few lines than if you hit a line, think you know where it's at, and have to replace a 300-foot line when you didn't have to. You just had to have us come out here and locate it.
Our purpose out here doing the locates for the sewer lines, the contractors do their own one-call system, but the one-call system does not locate private utilities. So that's where we come into play. We'll come out here, locate all the sewer lines for the contractor. If we have to do a hydro excavation, a verification dig, we will need to do our own one-call ticket. Even though we are working for the contractor, we still need to make sure that we are doing our own one-call ticket for our own digs. Right now we have 2 teammates out here on this project. We have our camera operator who's inside the truck running all the controls, and we have our technician out in the field locating the camera head and giving communication back to the camera operator via walkie-talkies, 2-way radios, and the camera operator is inputting everything into the computer so that the video will have an overlay and have all the depths and distances, and all the information is coming from the technician in the field.
Yeah, so pretty much when we put the tractor in, I just drive it down there, get up to a lateral, and then I've got the different controls on the camera, or on the tractor here in the main. So I shoot into the lateral, I let the other guy that's out there sounding know, and he locates me while I'm running up and gives me my depth at the end. I write it down and put it in the computer.
Mr. Bergstrom is going to expand on level B, and it's important to know that in the S.U.E world, level B can take place months before excavation in the design phase, or right before excavation, like you've seen here with Pipeview America and Bloodhound.
And that brings us to S.U.E level B, which is a geophysical means. This could include many things: RF locating, metal detectors, GPR or sonding. In this case, if we're talking about televising and sonding, this would be where level B falls in the project timeline. If our initial assumption of where the utility was here, with each level of S.U.E, we get more accurate on that.
Sam, in another lateral, please confirm 2235.
Confirmed. 2235.
Copy that, thank you, sir.
Locating a sewer camera is actually locating a sonde. A sonde can look like this. And what a sonde does is it transmits a field. And that field then is detectable at the surface with a receiver. Now, sondes come in different shapes and sizes. Sondes are also the way that the horizontal directional drill rig is guided to put pipe or conduit where the operator wants. A sonde emits a pumpkin-shaped field. If you can imagine a pumpkin on its side, those lines on the pumpkin represent the lines of the field. At the surface, what the locator sees is a point. So as the sonde moves, such as in the sewer camera configuration, as the sonde moves, the locator moves and is tracking a series of points. Pretty soon you have a connect the dots scenario that illustrates where the underground sewer lateral or underground sewer main is located.
Basically what I'm doing is he's rolling up the main, I'm locating him with the sonde, going from the main to the curb, and I'm getting him a depth at the curb when they're boring, or if they're open cutting and they just want to know how far they can dig down so they don't hit the pipe. A little more, keep going. Right there is good, right there is good.
Copy that.
My depth is 6.25 at the curb.
At 6.25 at 15.4. 625 at 15.4. Thank you.
6.25 at 15.5 is from the sewer main to the back of the curb. It's just getting an accurate depth for the contractor. So when they're digging, they know exactly where the pipe is.
Let's talk a little bit about how depth is calculated. The sonde emits a field that loses strength over distance. And that decay of signal is a constant. It is a known, and it doesn't matter what the frequency of the sonde is. Your depth is going to be a calculation of signal loss against the three knowns. Bottom antenna signal strength, upper antenna signal strength, and the exact distance in between the coils.
So today we are locating for a contractor. We are locating the sewer system, so sanitary and storm, for bore mitigation. Our contractor has another contractor that is drilling and upgrading their electrical grid. So we're here to camera the sewers for that.
They're crossing the street with the boring rig. They'd be boring all the way across the street, all the way down there. And that's why we had to locate all these laterals to each house in the sanitary main. And then we'll have to locate the storm and all that just to confirm where they went and where they go, and just so they don't hit it, put a line through the sewer line and have to dig up the whole road, stuff like that. Using water, whatever, if my marks are wrong, they're digging a 4-foot trench in somebody's yard. They could be sitting there for extra couple hours just to try and find a line that I mislocated, or anybody. So it's important to know what you're doing and locate it right. People don't get hurt. There's a lot less accidents that happen. It's just all around, everybody work on the same page to be safe. Everybody go home to their families. Anytime you dig, you want to call 811, and then we go beyond 811. So we will locate the private utilities that most public utilities locators won't locate. You want to do another 10 feet?
10-4.
They'll locate your main and air off where they think the tap goes. You don't know where the tap goes unless you put a cameraman and locate it. And cities, they won't do that. You get somebody like us, that private locators, we do this every day. We're awesome at it. I mean, that's why we're all over the country doing this. I mean, we excel in locating private utilities. Like say they're boring across the street, I gotta do a 25-foot radius of their whole bore path. and locate anything close to it, and then confirm where it goes. So, like over here, they're boring on the right side of the road, but I still had to camera the north side, just show them where it goes.
So to communicate with other companies, like the bore crews, we do bore cards, and they're a fixed point off of a house or structure, and it's measurements for specific measurements for depths where you locate it, either your lateral or your main or whatever it is you're locating. So they can, if paint's gone or anything like that, they can go ahead and measure out and get to your specific point where you located it. And on that bore card is the depth and everything like that.
Some of the challenges that we come across out here in the field, you know, as these contractors are fighting for more and more underground space, you know, fighting for that key target area where they want to be at, there's a lot of underground cables there and different utilities there. So as our camera is traveling through, a lot of times that 512 frequency that the beacon's putting off, it's getting bounced off of the gas line or the phone line or whatever other utilities are down there. So a lot of times we have a hard time sometimes of locating, pinpointing exactly where we're going to be at, because there's so many utilities that are in there and so many utilities aren't marked correctly. So even if there's times that we have to do a hydro excavation and the markings are so far off because there's so many different utilities that are fighting for that same area.
Let's check in one last time with Eric Bergstrom to finish the S.U.E process.
The most intensive level of subsurface utility engineering would be level A, and that is to actually expose the utility and get a confirmed location by sight or touching that utility and measuring its exact location. Once in project construction, we should always look out for level A opportunities, and that would be if the utility was exposed any time during the excavation, every opportunity to take a measurement on that for its horizontal positioning, its vertical positioning, or to even drop a marker ball is extremely important.
This is a bore card we do for the company we're working for right now. It shows like the house is, and then each point has an X and Y measurement, and then your depth. So you need to come out there with a wheel, a measuring wheel, and like I come off the southeast corner of the house, I would just measure down 79 feet 3 inches, and it would be A, and then X would be east and west. So it'd be 75 feet going west, and that'd be your point A. It shows you where the sanitary main is, where the laterals are going, the proposed bore path, just stuff like that we map out. Or if we're doing other utilities, you'll have like green or yellow for gas, pink for GPR. The green is the path. Each map got a legend, and it'll tell you what lines mean what. Like right now, this green means proposed C face. So that's what they're boring in, the green. It's gonna be C phase electric.
What we would do is we would be out there walking with their foreman saying, hey, 8 feet, 8 feet, 8 feet, 8 feet, 8 feet. You guys come through and you guys drill at 2 feet. You guys are good. And then after they do the drilling, we'll go back through there and do a post to verify, hey, everything looks good. You guys are safe. These properties are safe.
Now, have you seen that business increase over the last 2 years?
We have. There's been a lot more requirements from municipalities saying, hey, if you guys are coming in my town doing work, we have to make sure these residents are safe here. So there's definitely a lot more demand.
I mean, we've noticed that in the Midwest and out east and south, our markets, where the utility and the facility owners are putting in replacement lines or new lines into new communities, developments, etc., and requiring that. And it's a good thing, you know, to invest in that technology. It's there, and they know that they're not going to have a cross-bore that could eventually, you know, be a big problem.
Right. So our system, we don't erase anything, so we always keep everything on file. That way, if a contractor ever calls us up and says, hey, this homeowner at 123 Main Street, they've got a damaged sewer line, Well, I can send them the video, I can send them any information they need to verify that, hey, when we left here, we did pre and post construction for you guys. This property is safe. This damage was not caused by you guys, and here's a video proof for it.
What's this tap look like? Straight up or like that angle one from before?
Straight up, but I mean, yeah, it's pretty much straight up.
This could be deactivated then. You're pretty far north of 31.
That I'm gonna run it just to be safe. Just run it up like 10 feet or so, just to be safe.
Copy that. I'll let you know.
Copy that. Rolling out. Here we go. Get past the initial debris, but now I'm pushing something along, so I've got no visual. So if I stop, let me know.
Copy that. Yeah, go. Do me a favor. Go another 15 feet. I want to see if this goes to the right or if it stays straight.
Copy that. Copy that.
You're at the curb right here. If you want to get this depth.
Let's go to foundation. Just verify what property this is.
Copy that.
I hit something. I'm stopped dead right here. Visual screen blacked out.
Copy that. You are on the south side of 2235, so this could be deactivated.
I was moving freely and then all of a sudden hit like a wall, so I've got no visual. You know what, stand by.
And sometimes the property can have two laterals. It kind of depends on what type of property it is. But a lot of times you won't have two laterals per property. So this one does. The first one, we had water running out of it. So that's our active lateral. This one, as soon as I jumped into it, there was debris at the beginning of the lateral. So we are assuming that this is going to be a deactivated lateral, which means it's capped up close to foundation, and they wound up moving their lateral to a different spot on foundation.
So WinCam is how you document the sanitary lines or storm lines, the integrity of them. If there's any cracks, blockages, or anything, it's for the engineer to look at it. So we give a score like 1 through 5, and it'll tell the engineer how bad the pipe is. Instead of going back and looking at each video, then just look at the PACP and see what score it gives and see the integrity of the pipe that went. And then you mark the footage of the laterals, tap, factory made, break in, all that good stuff.
Put some hand pressure on it, I guess is what you would call it, just to free it from itself from being stuck. I don't know what that is. So every once in a while you have to just kind of give it a little tug or so. We got her back. I don't know how, but we did. Now I gotta clean my camera off, which the only way to do that is if there's a little bit of water on the bottom of the sewer. I'm just dragging along the bottom there and try and get some water on it and get a better picture. It's nice though, the flow's coming towards us, so that the pressure of the water going down the sewer is just gonna kind of clean everything off there as I push out. There we go. Got some visual again. Go ahead and try and locate that lateral again.
So I've kind of covered a couple different tasks here at Pipe View. Started off on the camera truck, worked my way over to the jet truck, cleaned the sewer mains. And I think one of the weirdest things we've seen, I was running the jet truck with the camera crew, and they said, "Tony, you got to come look at this." So I go over there, and there's a hockey stick sticking out of the sewer line. what we're looking at is the plastic part of the hockey stick. I'm not sure how far up the wood piece went, if there was a wood piece there, but I have no idea how they got a hockey stick in a sewer line.
We find a bunch of random stuff. A lot of times people like repair their clean out or something, and their clean out lid or even part of their entire clean out will wind up falling in there and gets jammed in there sideways. I mean, especially out here they got big mains out here, so there's always a bunch of different stuff out here. I think the most difficult part about doing it is getting up to a lateral or a tap that's offset. So like it would be sticking out into the main a little bit more, then your chute doesn't have the ability to get into it to launch into it.
You want to always better yourself, learn. If you're not learning something new every day, then there's something wrong. I mean, I've been doing this for the sewer business for my 6th year, and I'm always learning something new. Always somebody that's in the business longer than you, always pick their brain, see what they know, pick some information. Always try and learn something, because it's hard to teach somebody that knows everything already. You know, you gotta have that mindset of wanting to learn. And a lot of what I do is like a puzzle. So they'll give you a piece of the information, and you gotta put everything else together. It's not easy. It's not always easy. You gotta work. I mean, we're always outside, winter, summer, 100 degrees, 20 degrees, you're out there locating. We don't stop, ever. I mean, but I love my job. I'd rather be out here in this beautiful sun than sit in a cubicle, office, and computer.